Today, guys, we'll be doing section 11.2 with the chi-square test for homogeneity and the chi-square test for association. First, let's learn about what the chi-square test for homogeneity is. It is a test to determine whether the distribution of a categorical variable is the same for each of several populations or treatments. Remember, when using a chi-square test for homogeneity, you must use a single categorical variable with two or more independent samples. Moving on, we're going to be talking about the chi-square test for association. This is a test to see if there is convincing evidence of an association between the row and column variables in a two-way table. For example, like the problem we have on the screen, we'd be doing testing for an association between the gender and their favorite color.
So now we're going to go over how to choose the appropriate chi-square test. The chi-square test for homogeneity requires independent random samples from each population, and it compares distribution of a variable such as party affiliation between multiple populations. A chi-square test for independence usually sees if there's an association between two things, such as anger level and heart disease in a single population. So now there's a four-step method to solving these chi-square problems. There's the state, plan, do, and conclude. So for the state part, you have to choose whether to use homogeneity and independence. And so when you choose that, for homogeneity, you would say that for the null hypothesis, there is no difference in the distribution of a categorical variable for several populations or treatments. And for the alternate, you say there is a difference. For independence, you would say for the null that there's no association between two categorical variables in the population of interest, and for the alternate, there is an association. And so for this example, between coronary heart disease and anger management levels, the state would read, the null hypothesis that there is no association between anger level and heart disease status in the population of people with normal blood pressure, and the alternate would say there is an association between anger level and heart disease.
The second step to solving these problems is the plan step. So in the plan section, you need to check the conditions for performing either the chi-square test for homogeneity or the chi-square test for independence. But don't worry, both these tests have the same conditions you need to check. So condition 1 is random. This means that the data should come from independent random samples or the groups are from a randomized experiment. The second condition is the 10% condition. So when sampling without replacement, you need to check that n is less than or equal to 1n over 10. So essentially, check if the population is more than 10 times bigger than the sample. And the third is large counts, and this is all expected counts, or at least 5, not all observed counts, all expected counts. So the third step to solving these problems is the do step. So to calculate the expected count for each box in the matrix, use the formula seen in the bottom right corner, which is expected count equals row total times column total all over table total. So once you have all these expected counts, you will use the formula in the top right corner, which is x squared equals the sum of observed minus expected squared all over expected. And when you do this, you will get a value for x squared. This is important. You need to learn how to calculate the degrees of freedom. And this is the number of rows minus 1 times the number of columns minus 1. So using this number for degrees of freedom and the x squared value calculated earlier, you can use the table C, which tells you what p-value, which gives you your p-value. And we'll now go over how to use a TI-84 calculator to do both of these tests. So here you see the practice problem on the right. Please stop it now if you want to read the practice problem. So to do it in your calculator, you're going to go second matrix, which is the x to the negative 1, and then you're going to go to edit. You want to edit the first matrix, and then you have matrix A, and you see it is a 3 by 2 matrix, so you go 3 by 2, and then you start typing in your values. So 49, 47, 15, 27, 32, and 30. So now I have that matrix made. We can exit this matrix. Now you can go to stat, tests, and we go all the way down to x squared test, which is what we were doing. The observed is A, the expected is B, it actually calculates it for you, the expected counts, and you click calculate. So now we have these values, and we'll see what the answer is. So as you can see, our x squared value is 3.21, which is what the book has, and our p-value, which it also gives you, is 0.1999, which is what this has here. And it also calculates the degrees of freedom, but don't forget to also write how you calculated degrees of freedom on your paper to get full credit.
So now let's talk about our final step in the state plan do conclude, our conclusion. Once you get a p-value from either a hand calculation or using your TI-84 calculator, you'll need to make a conclusion on the data you have gathered. An important reminder is that if the p-value is less than the alpha significance level, you will end up rejecting the null hypothesis. If this same p-value is greater than the alpha significance level, you will fail to reject the null hypothesis. Following along with our example, we would obtain a p-value of 0.1999, which is greater than an example alpha significance level of 0.05, leading us to fail to reject the null hypothesis. It is important to restate the null hypothesis in the context of the question in the conclude section. Now let's discuss some common mistakes and AP exam reminders. One common mistake is misidentifying which test to use or not properly stating it on the free response question. Another common mistake that arises in the do section is not explicitly stating what the degrees of freedom are. Finally, in the conclude section, make sure that you do not say accept the null hypothesis. The correct answer should be fail to reject the null hypothesis. One helpful reminder for the AP exam is to always use state, plan, do, conclude in order to get full credit on your free response questions. A test for association is also known as a test for independence. Now, if you have some time on your own, please pause the video and do some of the practice AP Statistics exam questions.